Good day, children. You are welcome to this class. In this class, we are going to be carrying out several revision question exercises in preparation for your upcoming CBT. I'm sure it is going to be your first time writing an exam in a computerized based. So in that case, it is very necessary and important for you to carry out several preparations. So I want to make this first CBT of yours memorable. So I've prepared some revision questions that we are going to be going through. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, up to 25 questions. I'm going to solve for you one after the other. Make sure you listen clearly, and after all these questions, I'm going to give you a study question. Yes, similar to these questions that you can use to cross-check if you are actually doing well and understanding the questions properly. And of course, I'm available to mark your work and to provide corrections where necessary. So let's start without wasting much of our time. The first question we have here is on lowest common multiples. Remember, our first topic was on LCM, multiples and lowest common multiples. The first question here says, which of the following is a multiple of 4? Yes. Which of the following is a multiple of 4? When you see a question like that, what it's asking you is to look for the option, which one has a multiple of 4? Asking you, which of the following is a multiple of 4? What are multiples of numbers? The multiple of a number is a number gotten by multiplying that number by a whole number. So when you multiply 4 by different numbers, which of these numbers are you likely to get? For example, 4 plus 4 multiplied by 1, it's not here. 4 multiplied by 2, not here. 4 multiplied by 3 is 12, it's not here. 4 multiplied by 4, 16. 4 multiplied by 5, 20. Yeah, then 20 is my answer. 20 is one of the numbers that we can multiply 4 to get. Therefore, 20 is a multiple of 4. So the question is going to ask you, which of the following is a multiple of 5? We are going to be checking 5 times 1, 5 times 2, 5 times 3. Which one is in the option? Which of the following is a multiple of 2? 2, 4, 6, 8, 10, 12. That means you must know your multiples very well. The second question you are going to be expecting is on common multiples. I'm going to be asking you questions on common multiples. Which of the following is a common multiple of a group of numbers? For example, 8 and 4. I can ask you, which of the following is a common multiple of 4 and 8? 8 and 4. Remember common multiples. Common multiples are multiples that are being shared by 2 or more numbers. That means you have to write the multiples of 4 as 4, 8, 12, 16, 20 continuously, and you write the multiples of 8 as 8, 16, 24, 32, 40, and so on. And then you are going to look for the common multiples. Which of the following is a common multiple? You must have circled them out. You have 8, you have 16, and all of that. So you are going to check the option if you see any of the common multiples there. Is that taken? Now, in the next question you are likely to see is how to calculate the LCM of numbers. I'm going to be asking you to calculate the LCM of a set of numbers or a group of numbers. I can ask you calculate the LCM of 4 and 3, calculate the LCM of 5 and 6, calculate the LCM of 4 and 8. And remember, I taught you 2 different methods of calculating LCM. The most effective method is the division method. Yes, the division method of looking for LCM. You have to practice it very well. Why? Because sometimes if you are using the listing method, you can have a very huge amount of number, and it will be impossible for you to list all the multiples. But when you are using division method, you don't really have to go too far. All you have to do is to learn how to divide them. So I'm going to take an example on the division method for you so that you can practice it. The question I have here says, what is the LCM of 5 and 8? Looking for the LCM of 5 and 8. You draw your division sign this way. And as I told you, what you do is you look for a number that can divide any of the number, the smallest number, starting from 2. Can 2 divide any of them? 2 cannot divide 5 without remainder, but 2 can divide 8. The moment 2 can divide one of the number, it's not compulsory that it must divide all the number. The moment it can divide one of the number, then you can use it. So since 2 can divide one of the number, we are going to use 2. Remember, all our divisors, we are going to write them here. So when you use 2 to divide 5, it's going to have a remainder. Don't divide if you are going to have a remainder. Just write that 5 again. Because 5 divided by 2 is going to be 2 remainder 1. So just write 5. But 8 divided by 2 is 4. Now we are done with the first line. It is very, very important that you follow these steps carefully so that you don't miss the questions. The second one, we are also going to check, can 2 divide? Not that you just go to 3, no, you still check 2. Can 2 divide? If 2 can still divide, 2 can divide 4, even if it cannot divide 5. Therefore, we still use 2 again. But 5 divided by 2, remember, is going to have a remainder. Therefore, we still write our 5. And then 4 divided by the 2, we have 2. We are done with this. Now here, you are still going to check, can 2 divide? We discover that yes, 2 can divide 2. 2 divided by 2 is 1. But 5 cannot be divided by 2. But since 2 can still be divided by one of the numbers, we are still going to be using 2. So 5 divided by 2, remember we still use 5. And 2 divided by 2, we use 1. We get 1, I mean. Now you can now see that we have been able to convert this to 1, remaining this. Can 2 divide this? No. Can 3? No. Can 4? No. But 5, yes. Therefore, we use 5. And 5 divided by 5 is 1. 1. So how do we get our LCM finally? Our LCM, we are going to multiply all these divisors. 2 multiplied by 2 multiplied by 2 multiplied by 5. So that's 2 multiplied by 2 multiplied by 2 multiplied by 5. So 2 multiplied by 2 is 4. 4 multiplied by 2 is 8. And 8 multiplied by 5 is 40. Therefore, our LCM is going to be 40. I need you to practice this method very, very well. It's very important that you know how to use this method. Though I'm having a variable question for each and every question I'm going to solve for you. Now let's go to the next question we should learn. After our multiples and LCM, we went into factors and highest common factors. Actually, this is for the JSS1 and the JSS2. This is a combined revision. Okay, so we went into the part of what? Factors and highest common factors. And I told you that factors are numbers that can divide a given number without leaving a remainder. Without leaving a remainder. A factor of a number are those numbers that can divide that number without leaving a remainder. For example, what are the factors of 16? The factors of 16 are the numbers that can divide 16 without leaving a remainder. For example, 1 can divide 16 without leaving a remainder. 2 can do that because 16 divided by 2 is 8, remainder 0. 3 cannot do that because there will be a remainder. 4 can do that because 16 divided by 4 is 4, remainder 0. Yes, 8 can do that, and 16 These are the factors of 16. These are the numbers that can divide 16 without leaving a remainder. What are the factors of 12? The factors of 12 are those numbers that we can use to divide 12 without leaving a remainder. Example: 1, 2, 3, 4, 6, and 12. These are the factors of 12. So this is how you look for factors. You look for the numbers that can divide that number without leaving a remainder. For example, you might see questions like, which of the following option is a factor of this? I can ask you, which of the following is a factor of 20? Which of the following is a factor of 10? You have to look for the option and check if you can see any of these factors there, and then you take it. If I should ask you which of the following is a factor of 16 and my option says option A 2, option B 3, option C 4, and option D 5. When you check, you see that the only factor you can see here is 4, and then 4 would be your answer. Now, after factors, of course, the next thing is common factors. Which of the following is a common factor of 16 and 12? I can write them like this for you. Option A 3, option B 4, option C 5, and option D 6. Which of the following numbers is a common factor? A common factor is a factor that is being shared by two different numbers. Which of these factors are in 6, are in 16, and is also in 12? It's just 4 only also. 4 is the only common factor of what? 16 and 12. So you must learn multiples, common multiples, lowest common multiples. You must learn factors, common factors, and highest common factors. Let me show you what the highest common factor might looks like. Remember, in the highest common factor, I taught you two different methods. I taught you the listing method and I taught you the prime factorization method. The same thing, I won't advise you to stick to the listing method. The listing method is just for you to really understand what the concept is. The prime factorization method is going to make everything easier for you. So if I should ask you to look for the highest common factor of, let me say 12 and 8, I need you to break them down into their prime numbers. Remember the prime numbers I give you to study: 2, 3, 5, 7, 11, 13, and so on and so forth. I told you to practice them and know them. We are going to break them into their prime numbers, into their prime factors. First of all, you are going to do 12. You can break 12 into what? 2 multiplied by 6. And 2 multiplied by 6 is not enough. Since this 6 is not a prime number, we still break it down to what? 2 multiplied by 6 is what? How do you break 6 down? 2 times 3. Remember, 2 times 3 is the same thing as 6. So we replace 6 with what? 2 times 3. And now you can see that 2 times 2 times 3 is what? Prime numbers. Therefore, this is it for our 12. Our 12 has 2, 2, and 3. Then for the 8, we can also break 8 into 2. 2 multiplied by 4 is 8. And 4 is not a prime number. Okay? 4 is not a prime number. Therefore, you can still break that 4 down into what? 2 multiplied by 2. So that we now have 2 multiplied by, instead of 4, we have 2 times 2, making everything prime. Now our 8 has 2, 2, 2. So after we have finally break it down into their prime factors like this, we just have to look for the ones that are common and bring them out, slash them out. You see 2, 2, we slash it out and we have 2 times. We see another 2, 2, we slash it out again, 2. But here we can't slash them out because they are different. These 3, these 2. It's not possible because they are not the same. Therefore, this is going to be our answer. 2 times 2 is going to be our answer. And 2 times 2 is what? 4. Therefore, our answer is 4. So I need you to also focus on this and practice it very well. This is supposed to be a revision class, not an explicit explanation class. We already have that class earlier. So practice this method of prime factorization very well. I'm going to leave a question for you under HCF also to practice. When you practice it, submit it directly to me. I'm going to mark it and give you a review on it for those of you that have access to me. So now, I've shown you some things we have to learn. The first thing is what? Multiples. The next thing is what? Common multiples. The next thing is what? I told you to learn LCM. The next thing, I ask you to learn factors. I ask you to learn common factors. And I also ask you to learn what? Highest common factors. So let's continue. What is the next thing we are supposed to learn? I need you to also do a serious revision on your fraction. Yes, on your fraction. What did I tell you a fraction is? I told you a fraction is a term that is being used to represent part of a whole. A fraction is used to represent what? Part of a whole. And it always have a numerator and a denominator. The number at the top is the numerator, while the number at the bottom is the what? Denominator. Now, having known that, there are 3 different types of fraction also. 3 major types. There are more than 3, but the major types are just 3. Proper fractions, improper fractions, and mixed fractions. And I told you that proper fractions are fractions whose numerator, remember, the fraction always has what? Numerator all over denominator. So a proper fraction has the denominator bigger. When the denominator is bigger, it is what? A proper fraction. And when you have the same fraction numerator all over denominator and the numerator is bigger, it's now going to be improper. This is one of the things we did lately, so it should still be fresh in your memory. When the denominator is bigger, it is a proper fraction, and when the numerator is bigger, it is an improper fraction. And then we talked about the last type of fraction, which is mixed fraction, where we say mixed fraction are the type of fraction that has a whole number and a proper fraction combined together. So you are going to learn the types of fractions and their examples. I give you examples of proper fractions where I told you can take 1 out of 6, you can take 3 out of 5 is possible, and so on. And I told you the improper fraction where I told you that you can't take 5 out of 2, you can't take 6 out of 5, you can't take 7 out of 3. So you must know the types and the examples. And the next thing you are going to learn is conversions. You are going to learn how to convert fractions from improper fractions to mixed fractions. And you also learn how to convert from mixed fractions to improper fractions. I'm going to carry out one simple example on that conversion so that it can be a form of revision to you. When you have a mixed fraction like 4 whole number 2 whole over 3, this is a mixed fraction. How do you convert it into an improper fraction? I told you multiply in a circular form starting from the denominator. You multiply 3 times 4, and then you add it to 2. That is, you do what? 3 multiplied by 4 plus 2 all over the denominator, which is 3. And then after this, you now have 3 multiplied by 4 is what? 12. Okay, 3, 6, 9, 12. 3 multiplied by 4 is 12. 3 times 4 is 12. 12 plus 2 is 14. And then we have 14 out of 3. You can see 14 out of 3 is an improper fraction. So we have converted the mixed fraction to an improper fraction. What if we want to convert this improper fraction back to mixed fraction? If we have 14 out of 3, what we do is we divide 14 divided by 3. For those of you that are confused, when I said 3, 6, 9, 12, remainder 2, you can go and count. Yes, if you are not ashamed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, this is just for you to understand the concept of what I'm teaching you. I don't really mean that you have to count 1, 2, 3. 14 divided by 3. How many 3 is in 14? 1, 2, 3. 1. 1, 2, 3. 2. 1, 2, 3. 3. 1, 2, 3. 4. 1, 2. It's not up to 2 again. It's not up to 3 again. So we have 1, 2, 3, 4. Remaining 2. So we have 4 remainder 2, which will give you an answer. This 4 is going to be your whole number. 4 remainder 2, and this 2 is going to be your numerator. And your denominator will not change. It will be the same denominator you have been getting. And then this will be your answer. You can see it's corresponding to this. It's still the same. So this is how you convert from improper fractions to mixed fraction, and from mixed fractions to improper fractions. So you are going to learn multiples. You learn common multiples. You are going to learn lowest common multiples. You do revision on factors, common factors, and highest common factors. You are also going to work on your fractions, the types of fractions also, and you are going to work on your conversions. Very, very important. I'm going to set questions on this for you. Now, let's now step up our game into the higher level. I think all this I've been talking about is majorly for the primary 6 and JSS 1. But for the JSS 2 and JSS 3, you are also going to see these questions, similar questions in your CBT. You are going to see them in your CBT. Now, let's step up our game. Let's go into the topics that are exclusively for the JSS 2 and 3. Although some of the JSS 1 also participated. Some of these topics are standard form and approximation of numbers. Yes. So you have to know what standard form means. What are standard form? What is standard form? I told you that standard form is a way of writing large numbers or small numbers. Huge amount of numbers or very small amount of number in a much easier way in their powers of 10, using the powers of 10. So standard form deals with multiplying by powers of 10. You should know that whenever you see a number multiplied by 10 raised to the power, that is a standard form. Then after you learn that, you are supposed to also know how to convert numbers to standard form, or converting numbers from standard form to their ordinary form. Let me see the kind of sample questions I have over here. Okay. You might be asked to rewrite 0.00536 in standard form. How do you do this? 0.00536 in standard form. How do you do that? First of all, you have to identify your points, which is the first thing I told you. Remember, I told you the structure of your standard form should be in such a way that you are going to multiply a number by the power of 10. And this number you are going to multiply must not be up to 10, and it must not be smaller than 1. So this number must be up to 1 and it must be smaller than 10. So when we are doing that, we move our points. And when you are moving your point, you move your point and make sure that there is only one number before the decimal point. When you are writing your standard form, you don't write 23.614. No, it must be only one number. Either it is 1 point or 2 points or 3 points or 4 points or 5 points, 6 points, 7 points, 8 points. That will be what? 5.36. You can see there's 5 points here, 5 points. You cannot say 53 points. That one is not accepted. But we accept 5 points. So multiplied by 10. Remember, standard form is multiplied by 10. Raised to the power. How many times did we move it? 1, 2, 3. And we moved it where? To the right. This is where problem always comes. Make sure you know when you move it to the right, you use negative. We moved it 1, 2, 3. To the right is negative, and to the left is positive. So right is minus and left is positive normal number. So this is how you convert from standard from an ordinary number to a standard form. Are you getting it? We have other examples. If you are still not clear with this, you can still reach out to me privately. Now the next thing we'll talk about is how to convert from this standard form back to its original form. So let's say the question you were given is, let me look for the question here. Let's say we have 3.21 multiplied by 10 raised to the power of 4, and you have to convert this to its original form. You have to convert it to its original form. What do you do? When you are seeing positive 4, what does it mean? Look at it. When the point is being moved to the left, it is positive. That means this point came from somewhere here. Look at it. This is 3.21. It has been moved to the left 4 times. That is why you are saying 10 raised to the power of 4. So you have to move it back 4 times to where it was before. So if you are moving back, it's going to be opposite. 1, 2, 3, 4. And the point would be here. Okay? Therefore, we have moved the point from this place to this place. And these places that don't have anything, in mathematics, nothing means 0. Therefore, you now have 3, 2, 1, 0, 0 as your answer. Because positive 4 means it has been moved to the left. So what you are asked to do now is to move it back to where it was before, which is to move it to the right 4 times. You move it, and whichever space is empty, you replace it with 0. So you can be asked to convert numbers like, let me say, 42169 to standard form. Remember, when you see an ordinary number, the point is here. Remember, I told you you cannot be having 42,169 in standard form. You can only have 4 points. Therefore, you are going to move this point until it gets to the point where it's going to be 4 points. How many times? 1, 2, 3, 4 times. So we are going to now have 4 points. Yes, this one is accepted. 4.216, everything will be the same. 69 multiplied by 10. How many times did you move it? 1, 2, 3, 4. This to the power of 4. So This is how you carry out conversions in standard form. The next thing now is for us to go to I think the last topic we should be learning, which is approximation. Approximating to place value, approximating to decimal places, and approximating to what? Significant figures. Three different. We'll take it one after the other and we'll round up this revision session. The first one is approximation to place value. I told you we have different place values. If you have a number like 5, 6, 4, 3, 2, let me say 0.98473. From this point to the left, we have units. This should be in your memory. We have tens. We have hundreds. We have thousands. We have tens thousands. We have million continuously. Then to the right, we don't start from units again. We start from what? Tens. We have tens. We have hundreds with a th. We have thousands with a th. We have tens thousand with th. We have hundreds thousand, like that. So when you are asked to approximate, you are going to be given instruction on where to stop, and you must stop at that very point. Don't stop one number to the point or one number after the point. You must stop at that very point. Let's carry out an example. I can ask you to approximate this number now. How do we pronounce this number? This is 56,432.98473. This point here is the what? Decimal point. So you are asked to approximate this, let's say to the nearest hundreds. When you hear the word to the nearest hundreds, it means you are going to stop at the point of 100 in your place value. That is where you write the last number. The last number you are going to write must be under the hundreds. If I say you should approximate it to the nearest 100, you are going to write the last number at the 100. That means, where is our 100? Look at our 100 here. If you are to approximate to the nearest 100, you are going to stop here. That means you are going to write 564. 56 what? 4. To the nearest what? 100. But the moment you write that 564, what did I tell you? I told you that the remaining numbers are going to be turned into zeros. But before that, before you turn all the numbers into zero, you are going to check the very first number you want to turn into zero. Where is the first number we want to turn to zero? After the 100, remember this is where we stopped. 100, 4, 4, 4, under 100. The next number is 3. We are going to change this number into 0 and all the numbers. Before we change it into 0, you are going to check, is it up to 5? If it is up to 5, we are going to round up this number 4 by adding 1 to it. But if it is not up to 5, we just change everything to 0. Like in this case, it's not up to 5. Therefore, we change 3 and 2 to 0, which is 0, 0. We put our point if you like. Remember, I told you all these zeros are useless, but you can write it to make sure there is no error. This is your starting stage. So you have 556,400. So if I should ask you to approximate to the nearest 10,000, where is our 10,000? This is our 10,000 here. Are you seeing it? That means this is the only number I'm going to write. All the remaining numbers will be turned into 0. This is going to be the first and the last number I will write. Therefore, it's going to be what? 5. And then I'm going to change all the remaining numbers to 0. But before I change them to 0, I'm going to check this very next number. The very first number I'm going to change to 0. Is it up to 5? And we can see that this number is up to 5. Therefore, we are going to round up this one. We are going to add 1 to it to make it 6 instead of 5. It will now be what? 6. And then I can now change everything to 0. This is 0, 0, 0, 0. 0, 0, 0, 0. Point. Everything still changes to 0 like that. So this is how you approximate to what? Place value. That place value you are asked to approximate to, that is where you write your last number. And then you check the next number if it is up to 5. If it is up to 5, you will increase that number with 1. If it is not up to 5, you leave it like that. Now the next type of approximation is when you approximate to decimal points, decimal places. You can be asked to approximate to 2 decimal places. 2 decimal places means leave 2 numbers after the decimal point. 1 decimal place means leave 1 number after the decimal point. 4 decimal places means leave 4 numbers after the decimal point. For example, let us round to 2 decimal places or 2 DP. 2 decimal place means I'm going to write all these numbers and I'm going to leave only 2 numbers after decimal point. Where is the decimal point? Look at it. And then I'm going to leave 2 numbers. 1, 2. I'm going to leave these 2 numbers and then I will change the remaining ones to 0. That means my answer is going to be 56432. 56432 point, and then they said I should leave 2 decimal places. 1, 2. That is 98. I mean 2 decimal places, 2 numbers after the decimal point, and then I will change the remaining ones to 0. Don't forget, before I change them to 0, I'm going to check this first number if it is up to 5. In this case, it is not up to 5. Therefore, I don't need to round up. I don't need to change anything. I'm going to leave my answer like this. And if I like, I add the remaining zeros. So if I'm asked to approximate to 3 decimal place, how is it going to be? It means I should leave 3 numbers after decimal point. 3 numbers after decimal point. This is the decimal point. 1, 2, 3. Okay? So I'm going to leave these 3 numbers after the decimal point. That means my answer is going to be what? 564321. I mean 56432 point. I will leave 3 numbers after the decimal place, which is 3 decimal places. 1, 2, 3, which is 984. Before I change these ones to 0, I'm going to check this first number. Very, very important. Is it up to 5? It is up to 5. This is 7. Therefore, I'm going to round up. It is up to 5. Therefore, I'm going to round up this 4. I'm going to add 1 to it to make it 5. It's not going to be 4. It's going to be 5. So this is how we round up or round down to what? Decimal places. Approximate to decimal place. The last one that is somehow a little bit confusing is the significant figures. Now, when you are to round or approximate to significant figures, they are trying to tell you how many valuable numbers you should leave. And I told you that the insignificant figures are 2. The insignificant figures are different 2 types of numbers, and they are both zeros. They are leading zeros and what? Trailing zeros. What are leading zeros? Leading zeros are the zeros that came before the number started. You pronounce this number as 24. You don't pronounce it as 000024. All these numbers here are what? Leading zeros, and they are insignificant. And the same thing after the point. After the point and all your decimals, the last zeros, they are also insignificant. They are called trailing zeros. So these zeros at the very beginning of the number and these zeros at the ending are what we call trailing and leading zeros. And they are not significant. The only zero that is significant if the zero is in the center here. So let's take an example. 0.00143, and you are asked to approximate to two significant figures. So two significant figures means we only need to know. Remember, all these zeros at the back, they are useless. You don't count these ones. You count only these real numbers here. And you have to count only what? Two significant, which is 1, 2. That means you are going to only write 0.0014. This is where you stop. Don't forget, before you stop, you are going to check if this number is up to 5. If it is up to 5, you increase this one. For example, in a question like 0.136984, and you are asked to approximate to 3 significant figures, they mean they need only 3 real numbers. What are those 3 numbers? 1, 2, 3. That means you are supposed to stop here. Remember, don't count zeros. Don't count zeros. Count real numbers from 1. Therefore, we are going to have 0.123, which is 136. But before we change all these ones to 0, never forget, you are going to check if this is up to 5. And of course, here it is up to 5. We are going to add 1 to this one to make it 7. And yes, here are the things you are supposed to be good at for you to do well in today's CBT. Practice more. Yes, take your time, practice, study, and I promise you, you are going to do well, and it's going to be a memorable exam for you. Have a nice day, and see you in our next session. Bye.